Hi folks, we're going to take a look at question 4 from the Unit 5 assignment. So they give us these 2 points, -1, 2 and -4, -1, and they ask us to find 2 different points that would form a right angle triangle along with these given points. Okay, and one of these triangles has to be isosceles. So this is where we run into a bit of an issue because an isosceles triangle has 2 sides that are the same length, and we don't have a way to determine length with a formula yet. That's something you'll see in grade 10. So we're going to have to try to come up with a solution to this without a length formula. Okay, so let's start with finding just a third point that'll form a right angle triangle. So we know that if this is one of the sides to the triangle, okay, what I want to do is I want to find a second side that's going to be perpendicular to this one. So I'm going to use the slope for that. So I see that the rise, okay, on this as I go from point 1 to point 2 is 3, and the run is also 3. So that means that the slope of this line is equal to 1, 3 over 3. Okay? So what I need to do is I just need to create another point with one of these 2 points that's going to have a slope that's the negative reciprocal of 1, and the negative reciprocal of 1 is just, well, -1 over 1, so just -1. So I need to create another line along with one of these 2 points to get me a slope of -1. Okay, so you can choose to work with either one of these, that's fine. I'll choose to work with this bottom one here. So when we talk about slope, we need to have, you know, if you think of the slope as -1 over 1, that's my perpendicular slope that I'm looking for. Okay, as x goes up by 1, y goes down by -1. Okay, so I'm going to go backwards here. I'm going to say as x goes down by 1, so I'm going to do the opposite. Well, the y value is also going to have to do the opposite. It's going to have to go up by 1. So if I take this point here, -5, 0, okay, well, let's test the rise and the run here. Okay, the rise goes down by -1, and the run, okay, goes up by 1. So the slope of this line here created with the, I'll use a ruler for that, with this point, okay, is just going to be -1. Okay, and because the slopes of these 2 lines are negative reciprocals of each other, there we go. I can now draw my triangle. Okay, there's my triangle. So the point, one of my answers here will be the point -5, 0. Okay, so again, just to recap why this works, okay, the slope between these 2 points is rise of -1, run of 1. So slope is -1, and then the slope of this line here, rise of 3, run of 3, 3 over 3 is equal to 1, negative reciprocals of each other. Okay, so now let's try to find a second point. When we think about any point that's going to be on this line here, which has a slope of -1, okay, any point on this line could be chosen to form a right angle triangle, because if I choose that point there, connect it to that one, I'll have these 2 lines which are perpendicular. Choose that point there, okay, 2 lines that are perpendicular. I can even choose a point on this side, okay, these 2 lines will be perpendicular. So I can pick any point on this line to create another right angle triangle, except I want to try to find the one that's going to give me an isosceles right angle triangle. Okay, and so this is where we've got to use our intuition a little here. So I want to try to find another line that has the exact same length as this one here. Okay, but when you think about the line joining these 2 points and the rise and the run, well, you're creating a right angle triangle. Okay, think about what you know with Pythagoras. Okay, if I create another line whose rise and run both have lengths of 3, okay, then I'm going to have a hypotenuse that's going to be the exact same length. So what I'm going to do here is I'm going to choose, okay, a point on the line such that the rise and run both have a length of 3, just like these through here. So 1, 2, 3. Notice I'm not going to care about the sign, I just care about the length of these side lengths of the triangle. So 1, 2, 3, and then 1, 2, 3. So this point here, okay, if I now draw that line, we see that this line here and my original line will have the exact same length. Okay? Because if I think of this right angle triangle, the two non-hypotenuse sides are the same in each of these triangles, so the hypotenuse sides must have the same length. Okay? And so here, there's my right angle triangle, still has this right angle here, except now these two sides are equal length. Okay, so that point there would be -7 and 2. So my second point, okay, -7 and 2, this one would create the isosceles triangle. Okay, so here we see an example where we weren't using equations to solve the problem. Okay, because we don't have a length formula, we had to use a graph and use our intuition, but we had to make an argument to show why this length here was exactly the same as that length there. Okay, that's it for this one.